Now that we have the basics down of solving systems of equations and inequalities of two variables, we're going to take a quick look at what it would be like with three. Now, as we solve equations or inequalities, each variable represents a different dimension in space. When we were solving for only one variable, there was a single point on a line. Now when we were dealing with two variables, as we have been during this unit, we were looking at the intersection of two different lines, two-dimensional space. With three variables, we come out with three-dimensional space. And as such, we come up with different arrangements. Three dimensions involves a plane, a length and width traveling through space. So we can have three planes that intersect in any of these five configurations. And the reason these graphics are being shown here is they give us representations of how many solutions we should be able to expect. For the first three, there are no solution. So for these ones, there is no place where all three planes intersect at a single point. And that does happen occasionally. In this one, we can see that there is one solution where all three of the planes coincide. Now as we look at the last one, here, all three of the planes share a single line together, and so what we end up with is an infinite number of solutions. Now as we look at the different ways that these can be configured, we have not done any work with graphing in three-dimensional space, so graphing is not going to be a solution method that we're going to use. Also, we are not working with inequalities here. We are simply going to be solving systems of three-variable equations in order to come up with the solutions that we need. So let's take a look at how we can do this. First thing we're going to do is we're going to be solving these systems using elimination. Our main forms of solving, elimination and substitution, are going to be what we fall back to, and each one will have a couple of ups and downs. So let's take a look at elimination with these sets. What we have to do is we have to take the equations a pair at a time, and we're going to eliminate the same variable using different pairings in order to narrow down the number of equations that we have. For instance, if I take equations 1 and 2 in this first set and add them together, what I'll come up with is 2x, negative y plus y will eliminate itself, plus 4z equals a negative 4. Then, if I take equations 2 and 3 and add them together, I will come up with 3x plus 5z equals a negative 3. So now I have everything down to two equations, or two variables. And from here, I'll be able to use the methods that we've practiced so far in order to get things solved down to 1. So, what's our lowest common multiple of 2 and 3, or lowest common multiple of 4 and 5? It's going to be a lot easier to find it for 2 and 3, so we will take off there. If we find our lowest common multiple of 2 and 3, it is 6. So I'm going to multiply the first of my new equations by 3, and I come up with 6x plus 12z equals negative 12. And multiply the second new equation by 2, and I will come up with 6x plus 10z equals negative 6. Now I have 6x in both locations. If I simply subtract my equations from one another, I will end up with 2z equals negative 6, so z equals a negative 3. Next, I go in and I find what the solution, or using that, I'm going to start substituting back up into higher equations. So I had 2x, negative 3 times 4 is negative 12, equals negative 4. Add 12 to both sides. I get 2x equals 8, so x equals 4. Then I take both of these, my x and my z, and substitute back into an original equation. And I'm going to choose the first one. So I have 4 minus y minus 3 equals negative 1. Combining like terms, I have 1 minus y equals negative 1. Solving, negative y is negative 2, so y equals 2. My solution set, I know this is getting crowded in here, but my solution set comes out to be 4, 2, negative 3. And that is the location in three-dimensional space where all three of these planes will intersect each other. So a lot of back and forth, a lot of things going on here in order to make it work out. Next, let's solve the one on the right. So what we're going to do is, same thing, pick pairs of equations to eliminate a single variable. And what I'll do is I'll start by combining equations 1 and 2. I'm going to combine them through the operation of subtraction. And I'm going to subtract up to make it easier. So 2x minus x is simply x. Y minus y is 0. 3z minus 2z is z. 7 minus 3 is 4. So I have a new equation here called x plus z equals 4. Next, I'm going to combine equations 2 and 3. And the way I'm going to do this is first, like what we were doing before, I'm going to double everything in equation 2. Now, save a little bit of time, I'm just going to speak this out. And then I'll add them together. So 4x minus x gives me 3x. 2y minus 2y is 0. 6z plus z gives me 7z. And 14 plus 10 gives me 24. Now, I will need to combine these equations in such a way that it eliminates a variable. So what I'm going to choose to do is rewrite these. So I'm going to keep 3x plus 7z equals 24. Then I'm going to triple the second equation. I have 3x plus 3z equals 12. And then I will subtract these from each other, giving me a new equation of 4z equals 12, so z equals 3. Once I have that, I start substituting back up. I'm going to go next to my combined equations 1 and 2. I have x plus 3 equals 4, so x equals 1. And then take that and substitute it back up into one of the original equations. I'll have 1 plus y plus 6, that's 2 times 3, because z is 3, equals 3. Combining like terms, 7 plus y equals 3, so y equals a negative 4. This gives me a final solution set of 1, negative 4, 3, as the point in space where these intersect each other. Again, a lot going on here. Make sure you're following along and taking good notes. Now, substitution is not the only method that we have for solving systems of equations. Elimination is not. Substitution is another option. Now, in substitution, what we do is we start by solving one of the equations for a single variable. And you can see in this equation, equation number 2 here, we have an isolated y. And I choose to solve for that one because I can see in my other equations, each of them involve a 2y. So it will help to limit down what's happening. So if I solve this for y, I come out with y equals 4x plus 2z plus 1. Now I'm going to use that to substitute into the other two equations. So I have x minus 2 times 4x plus 2z plus 1 plus z equals negative 4. And in my third equation, I'll have 2x plus 2 times 4x plus 2z plus 1 minus z equals 10. Distributing, combining like terms, 2 times 4x is 8x, so x minus 8x gives me negative 7x. Negative 2 times 2z gives me negative 4z. Negative 2 plus times 1 is a negative 2. I have a plus z on the end here, so negative 4z becomes negative 3z equals negative 4. Same thing for the second equation. 2 times 4x is 8x plus the other 2x is 10x. 2 times 2z is 4z minus z is 3z. 2 times 1 is 2. And all that equals 10. Now if I were to simply add these two equations together, I get 3x equals 6, so x has to be 2. Now taking that, I can then go and find the value of another equation or another variable by using this 2x in one of these two equations. Both of them are equally sound. I just choose to do the first one. So I come up with negative 14 minus 3z plus or minus 2 equals a negative 4. Combining like terms, I get negative 16 minus 3z equals a negative 4. Adding 16 to both sides gives me 3z equals a positive 12. Divided by negative 3, I have z is equal to a negative 4. Now with both of these, x and z, I can go back up and solve for y. So negative 4 times 2 is negative 8 plus y. Negative 2 times negative 4 is 8 equals 1. So I have negative 8 plus y plus 8 equals 1. Negative 8 plus 8 is 0, so I have y equals 1. And my solution is 2, 1, negative 4. So the end result or end methods come out to be the same as with elimination, but in substitution you start by isolating a single variable. Now how would this look in terms of application into the real world? You manage a clothing store and budget $5,400 to restock 200 shirts. T-shirts are $12, polo shirts are $24, rugby shirts are $36. If you want to have the same number of t-shirts as polo shirts, how many of each do you have to buy? So what we have to do is start pulling out equations. If we have S, P, and R as our variables for T, P, and R for t-shirt, polo, and rugby, we will have the following. T plus P plus R has to equal 200. That's simply saying the number of t-shirts, number of polo shirts, number of rugby shirts is 200. Then if we go off of cost, 12T, because it's $12 per shirt, plus 24P plus 36R equals 5,400. And then the last piece, we have to have the same number of t-shirts as polo shirts, so T equals P becomes our last equation. Now going through and starting to solve this, we can do the following. We can begin by simplifying the second equation. All these numbers, 12, 24, 36, and 54, are multiples of 12. So if we divide everything by 12, what we come up with is T plus 2p plus 3r equals 450. The smaller numbers will make it much easier to work with. Then we have to remember this part, that t is equal to p. So any place in here that we have one of those variables, we can substitute it for the other. So let us replace the t's with p's. So what we end up with is p plus r is 200, and then p plus 2p plus 3r is 450. Simplifying these out, come up with 2p plus r is 200, and 3p plus 3r is 450. Again, everything in the second equation, our new second equation, can be divided by 3, so what we end up with is p plus r plus 150, or equals 150. Subtracting these two equations from each other, we end up with 2p minus p is simply p, r minus r is nothing, 250 minus 150 is, or 200 minus 150 is simply 50. So our number of polo shirts will be 50. And knowing that t-shirts and polo shirts are the same, our number of t-shirts is also 50. And then for r, well, 50 plus 50 plus r has to equal 200. So 100 plus r is 200. Subtracting 100 from each side, r equals 100. So how many of each type of shirt should be purchased? 50 t-shirts, 50 polo shirts, and 100 rugby shirts will give us the exact number of shirts and the exact cost for our budget. A lot of things happen in this lesson, a lot of different methods where we're combining things we've seen before. So make sure you review it and have everything ready to be used.